Now we will discussing about the digital filter structures. Today topic is digital filter structure. Generally the systems may be continuous or discrete time system. Discrete time systems may be finite impulse FIR systems or IR system. FIR system means that finite impulse response. That means the impulse response of the system is some finite value. IIR system means that the impulse response of the system may be some infinite value. Here the realization of the system means that we can obtaining the network by to the corresponding to the difference equation or transfer function of the system. For LTI system, the convolution principle can be employed to implement the digital filter. We know that generally convolution formula is nothing but y of n is equal to summation n is equal to 0 to minus infinity x of k into h of n minus k. So as well as for LTI system, the infinite response approach is not. For LTI system, IIR realization is not possible in the practical consideration. For the realization of FIR is described by the FIR implementation is described by the difference equation. Is the direct implementation is quite practical also. That means the FIR implementation can be possible to implement in the real time because we have some finite values. As well as we need to know about the two important things here: canonic structure and non-canonic structure. Here canonic means that the order of the system is equal to the number of delays in the structure, then it is generally called as a canonical. Non-canonical means that the order of the system is not equal to the number of delays is called as a non-canonical structure. Next we will discussing about the block diagrammatic representation. So that is nothing but block diagram. So the input-output relation can be expressed with the help of a time domain in the convolution form. That can be as nothing y of n is equal to k is equal to infinity. K goes from minus infinity to infinity. H of k x of n minus k. So or else we can represent in the linear constant coefficient difference equation, that is equal to y of n is equal to like this. As well as a digital filter implemented on a general purpose digital computer, or maybe in a computer in a software, or maybe some special kind of the hardware also. It is necessary to describe the input-output relationship by means of computational algorithm. So consider LTI system that can be represented with a difference equation. Now we have to find out the y of n for different values of n. Then we will get like this. So if you observe these three equations, the present output depends upon the previous values also. That means if you want to compute the present state of the output, it compulsory depends on the previous knowledge of the output also. So then the present value of the input sample and previous value of the input sample, knowing the data values of we multiply them by the appropriate coefficients, so minus a1, b0 and b1, then sum the products to complete the present value of the output. As a result of the difference equation 2 can be interpreted as a valid computational algorithm. So then we will implement the block diagrammatic representation for the y of n is equal to minus a1 into y of n minus 1 plus b0 into x of n plus b1 into x of n. For that purpose y of n is equal to y of n minus 1. For that purpose we are multiplying the y of n minus 1 is nothing but we are providing one delay. Y of n minus 1 is nothing but delay element. So that can be provided with some delay element, as well as that is multiplied with minus a1, that is added to the total response. So x of n is multiplied with the b0 symbol, b0 coefficient, as well as the input is also delayed with 1 unit, that is also multiplied with the b1. If you are summing all these two values of this value, we can get the y of n. That y of n is equal to here, y of n is equal to here minus a1 into x of n minus 1 plus b0 into x of n plus b1 into x of 1. So this is equal to this one only. So there is just a black diagrammatic representation for the systems, as well as just introduction point of the discrete filter structure also. Thank you.